Centripetal force and centripetal acceleration. Let us recall from the lab work. We identified quantities on which the speed of an object v performing circular motion is dependent upon. There were the radius of the circle r, the mass of the object m, and the force with which the object is being pulled F. V varied directly as the radical of R, or V squared varied directly as R. And V varied inversely as the radical of mass, or the velocity squared varied inversely as mass. Velocity varied directly as the radical of the force that is pulling it, or V squared was directly varying as the force. We could combine these together and write V varies directly as radical of F times radical of R divided by radical of M. Otherwise, we may write an equation as V squared is equal to a proportionality constant times Fr divided by M. If the constant is 1, then we may be able to rewrite this expression as F is equal to mv squared over R. We will establish that using the theory in the next class. What is this force we have computed just now? Here is a representation of the experimental setup we used. You see the PVC tube with a string passing through it and a force applied by a hanger in the bottom, with a mass being swirled around whose mass is m. R is the radius of the circular path and v is the speed with which it is going around in the circle. We avoided calling it velocity since the direction of the motion was changing all the time as it is going around a circle. This means there must be an acceleration. If the velocity is changing, there must be an acceleration. If there is an acceleration, then there must be a net force. You might have observed that the string was pulling it towards the pipe, which is the center of the circle. Since it is seeking the center, the force is called the centripetal force. The acceleration is called centripetal acceleration. So this raises two questions. Is the overhang length of the string really the radius? Is the tension in the string really the centripetal force? Or only a part of the string's tension is the centripetal force? This is something we need to think about before we come to the next class. It is the net force. Please remember that this is the net force. Centripetal force is a net force and not a force that should be included in a free body diagram. In a free body diagram, we talk about forces acting on an object. We never show the net force because the net force is what that is results from all the forces that are acting on the object. It is the net force required for an object to perform circular motion. That means the centripetal force is the net force required for the circular motion. Like sometimes you need a net force for an object to accelerate along a straight line. Same way, here it is the net force that is required for an object to perform circular motion. When a set of forces make an object to go in a circle, then there is an acceleration caused by the net force, which we call centripetal acceleration. If we compute the force corresponding to this acceleration, then it is called centripetal force. Few more questions to think about before you come to the next class. If the centripetal acceleration acts towards the center, is the centripetal force constant? Remember, force is a vector. Then what part of the centripetal force is constant? What happens to the centripetal force if the speed changes for the same radius? How does the force acting change in a circular motion in a vertical plane having a centripetal acceleration?